My name is Michael Otten. I go by Stoic the Dirt Hippie on Facebook, and my YouTube channel is Building with Stoic. I'm a traveling alternative builder and sustainable developer based out of New Mexico. I've done a lot of different things in my professional career, but my passion is earthen building. Uncle Mud invited me to the Permaculture Jamboree in 2022. They wanted to put a yurt on the site, and their plan was just to build a platform out of wood and then set the yurt on the platform. But I said, what would be really cool is if we put in an earthen floor and instead did like an earth coupled design. So when we first got here, this was all just a hillside, and there was no getting any machinery up here because of the topography and where the buildings are. I ended up coming out 2 weeks early to carve out this hillside into a flat area. I didn't really overthink that process, just mark out the area that you want to make flat, take off all the topsoil and roots and plant matter, and then just take from the high spots and give to the low spots, and eventually you realize that there's no more high spots and low spots. Everything's just flat. The event came along and the yurt hadn't arrived. This is actually an authentic Mongolian Ger yurt from Mongolia. It has yak hair ropes, canvas coverings, and a lot of it was just handmade in Mongolia and then shipped here, but the shipping took longer than anticipated. Next summer, 2023, the yurt's here, it's ready to go, but then I ended up getting to the event 3 days late. All the participants had pretty much committed to other projects by the time I got here, and so I didn't really have a lot of help. But even so, we did get the yurt put up. Not as easy as the Mongolians make it look. First thing I did was build this ring of large stones around the inside of the yurt to contain the floor. Obviously, it's just a lattice wall, so we didn't really have anything that the floor could pile up against. So the first layer of this floor is a gravel layer. That's for drainage. It's to allow any moisture that gets underneath the building, underneath the floor. It doesn't want to soak up and travel up into the floor from underneath. So if it rains and water that flows underneath can just continue to flow all the way under and through. There's another optional layer that you can add underneath the floor, which is an insulation layer. It depends on whether you want to use the floor as a heat sink or as a thermal battery. So a heat sink works to draw heat out of your interior space and down into the earth away. So it helps cool the space off. In a hot dominant climate, southern New Mexico, parts of Arizona, Texas, where it's hot day in and out for a significant portion of the year, you're more concerned with burning energy to keep the space cool in the summer than to keep it warm in the winter. You probably want to have your floor act as a heat sink, so it'll be earth coupled, and so you don't insulate it, and it can radiate the heat from the interior space down into the earth, where it'll just continuously draw heat out of your interior forever. In a cold dominant climate, which is most of North America, where it's cold day and night for a significant portion of the year in the wintertime, you might consider actually turning your floor into a thermal battery by insulating underneath the floor. And then that prevents the heat from your interior space from escaping out through your floor. And so if you've got a heater in that space and it's insulated under the floor, when it heats that space, that warmth soaks into the floor and stays there. And then when the heat goes off, it's going to radiate that heat back out as the interior space gets cooler than the floor is. Some ways that you can insulate underneath your floor: it has to be rigid. It has to be able to support the floor on top of it. So you can use rigid foam insulation, rigid foam boards. Something that's getting a little bit more popular now is foam glass. It's like they make glass, but they produce it in such a way that it's like a foam, and so it has all these air bubbles in it. It makes an insulated material, and it's like a gravel. Pumice stone, to a lesser extent, also kind of acts as an insulator because it's got a lot of little holes in it. Every 3 to 5 inches, whatever the material is, you want to make sure your floor is well compacted all the way up. That's key to having a sturdy floor. And then on top of that, there's a plastic moisture barrier, and they generally like to avoid using plastic out here for any purposes. I told them that it was an option, but highly recommended it because, any moisture that gets underneath can still wick up the gravel and travel up through the floor potentially, especially if there's a big rain event where a lot of moisture gets underneath. That plastic just blocks any water from traveling. Also helps discourage insects and plants from growing. There's several ways that you can build an earthen floor. A lot of people do full mud pours where they mix the entire floor as a mud mixture and pour the entire thing. The full mud earthen floor is a lot of work because you have to engineer all of the material. Say your floor is 5, 6, 7, 8 inches thick. That's 8 inches of mud that you have to mix. This floor is really popular because the bulk of your floor is just a compactable fill dirt. You might dampen the floor if it needs that to be able to compress, but it's just dirt that has enough, the appropriate combination of fines and aggregates to compress. That sort of dirt is used in civil engineering applications all the time. You should be able to go to just about any aggregate company that sells dirt and get a compactable fill or an engineered fill dirt, and that will have properties that allow it to compress. And if it's clay-based, you have to check, but you might be able to engineer all of your floor from that material. But very often you have the appropriate dirt just right under your feet, and so a lot of people want to use the dirt from their own property to do their earthworks. Earth building is extremely simple. It's not so simple that you can just take any dirt out of the ground anywhere and build a house with it. Last year I went around to several different places to try and find what might be the best place to source dirt for this project from, and I landed on the Lemon Tree site. So this is the first test that I do when I'm trying to determine if a soil is appropriate for construction, is the jar test. So I'll just fill a jar about halfway to 3/4 full with the dirt that you want to test, fill it the rest of the way with water, shake it up really good, make sure all the particles separate from each other and it gets fully soaked through and loose, and then let it all settle. The larger mineral particles will settle first, so you'll get your gravel and your larger pieces of sand at the bottom. Then the finer sand as you go up, and at the very top will settle a layer of silt, which is the transitionary layer between sand and clay. And at the very top, you'll get a clay layer. So on this, we have maybe like 20% fines, 80% very fine sand. And there's very little variation between the size of the sand. Usually for construction, for structural purposes, it's good to have sand which is sharp sand, like a limestone chat or something that has a lot of angular particles and various sizes, like you see some bigger ones at the bottom and some different sizes going through. That's really good for structural purposes. Sand like this, which is, it's round sand, it was formed by water, is very, very fine. This is great for doing like a plaster or finish work because your trowel just glides over it. Sand are mineral particles that are from 0.05 millimeters up to about 1/4 of an inch. That's not a scientific measurement. I base that on like what if you go buy sand at like a aggregate company. Then from 0.05 millimeters down to 0.002 millimeters are silt particles. Silt particles are very, very small, but they're not quite small enough yet that they are acting as a solid. If all your fines are just silt, your earth mix is going to be very weak. It's not going to be very resistant to moisture damage. It's going to just kind of crumble under your fingertip. Then from 0.002 millimeters and smaller, those are clay particles. They're mineral particles that are so small that they actually behave more like a solid when they all come together. And so when we get earth that has an appropriate amount of clay and silt and sands in it, and we get it wet, the water carries the clay particles around all of the sand particles, binds it all together, and then we get a structurally sound composition of minerals. It's really difficult to distinguish in a jar the difference between clay and silt because they're both so small, just with your eyeball. And so I accompany my jar test with another test called the cookie test, which is where I take a bit of that soil, wet it enough to work it like pottery clay or something, and then I wedge it, which if you've ever done pottery, you know you just work the clay, turn it, squish it, turn it, squish it to align the particles and help it get them worked into more of a solid. And then I just form it into about a cookie that's, you know, 1/2 inch thick to maybe 3 inches wide, and then let that dry completely. And then I broke it in half to check the inside to make sure it was dry all the way through. And then I just take a piece of this between my thumb and my forefinger and I try to crush it. And if you can't crush it, that means it's not all silt in there. If it was all silt, I would be able to crush this into powder very easily. But because it's got enough clay in there, that makes it very strong. And now at this point, if I see how strong the cookie is and I see that the sand to fines ratio looks good in the jar, that's enough to tell me that this is a good enough mixture to use for something non-structural, like a floor, pizza oven, plasters. If I know I'm going to be using the earth to do something like a structural wall for a home, that needs to have some more intense tests done on it. I'm going to make some adobe bricks and run some tests on them to get their qualities to make sure that they're structurally sound enough to support a building. But this was enough to tell me that this floor was strong enough, had enough clay in it to use as a floor. So we gathered a big dump trailer full, wheelbarrowed it in, dumped it on top of our gravel and our plastic, leveled it out, compacted it every few inches. We were going really hard, fast, heavy, so we just did kind of a rough level they have a site level here, but you can also use a laser level. Put a laser level out on the floor and mark a stick with the level that the laser is at, and you can take that around the floor to check your level. We were going to be able to lay mud floor just the very last day of the event, and so I was super rushed. I just took the earth as it was, laid it down, and didn't really do hardly any engineering on it, just to see if it would work. And it did not work. It just cracked all the pieces, completely delaminated. Delamination is when a layer of material doesn't adhere or bond with the layer underneath. Lamination is crucially important when you're doing earthen floors or earthen plasters. Each coat needs to be able to bond well with either mechanically or by soaking in and bonding with the layer underneath. And also it cracked horribly, like it had huge cracks all over the full surface. Shrinkage cracks are very common in earth construction, and very often they're not a big deal. They can just be repaired. Cracks form in structural earth because clay is expansive. When it gets wet, it expands, and you have to get your earth wet, of course, to shape it into a wall or a pizza oven or a floor or whatever you want to make. As it dries out, it shrinks again. And if there's too much clay in your mix, or if there's a lot of water in the mix, or if it's very uneven, and so certain areas are drying out faster than other areas, shrinkage cracks can happen. So here we are in 2024. First thing I did was pull up the old failed floor from the previous year and toss it out. Some people asked if you could reconstitute the floor from last year and make it into a new mix and reuse it. Technically, you could do that. You'd have to soak it, and then once you soak it, you lose a lot of control over the dryness of the material. It's generally a lot more work, but in theory, yes, you could absolutely put it into a pit and soak it up and use it in some cob or make another floor or something with. Once the old floor was all out, I soaked the subfloor several times to try and soften it up so that it would have the new material bond onto it really well. And I also roughed up the floor before we put our material down. I did a test where I mixed it 50-50 with the soil from lemon tree site and sand, 1-to-1 ratio, a 1-to-2 with the earth and sand, and then I think I even did a 1-to-3. The 1-to-1 ended up being plenty sandy, but it still had enough clay in it that it was drying up nice and firm, and so I decided to go with that 1-to-1 ratio. We started laying it out. This is a metal pipe that I pulled out of a scrapyard. I use these for screed boards. You lay this down on your subfloor, and if your subfloor is level and flat, your screed board will lay relatively flat. And then you get multiples of these, line them up in a row, make sure they're not farther apart from each other than your tool is wide, than your wood float or whatever you're using is. And then you take your float tool, this is a wooden float, and you just screed your material down in between the screed boards, and that keeps it flat. Another thing I did to prepare the subsurface for the new floor was to rough it up with a rake. Trowels, sharp implements, just gouge the floor really well. Not enough to alter the overall levelness of the floor, but enough to give the new layer mechanical something to bite into and more surface area for the water to soak into as well. So this is a wood float tool. This is a mahogany float. Any kind of masonry application where you're relying on compression and you're trying to make a flat surface, you need to use a rigid float tool like this wood float. Because you're putting pressure on the floor, and you just go in a circular motion around the area or a linear motion, and you make sure you're applying plenty of downward force to fully compress that material down in between your screed boards and make it into a solid surface. A lot of people, when maybe they're building their house or building a whatever project they're working on, they might have done some plastering before they went to work on their floor, and they're using metal trowels like this to lay their plaster on the wall, and they just kind of take those lessons and those wrist movements and try to apply them to their floor. It doesn't really work very well because metal floats like this are designed to be flexible, and so any application where you're having to press down into the floor, the trowel's going to be flexing, and you're going to be working that curve into your floor as you're going. The reason you have to use a rigid float is because this will stay flat even as you apply compression to the floor, and then that'll ensure that the surface stays flat. Once I determined my mix, I just started from the back of the building, working towards the door, laying down the screed boards. I had the site level here, and I determined a site that was generally 3/4 of an inch above where the subfloor was all around, and then I leveled my screed boards to that. Just used some of the material to pack under where I needed to, or dig them into the floor where I needed to, and used the site level to ensure that my screed boards were at the level, and then used my rigid wood floats to float the material in between the screed boards. Once you've got an area where your screeds are surrounded by earth and compacted and you're ready to move the screed boards out, you just pull them down or pull them out. Use your fingers to rough up the area where the hole where the screed board left behind in the earth, then fill that with some more material, and you can float that out using the surrounding material as the level for that area, and just float it until you can't see that hole anymore. Layer is going to be as thick as your screed boards are. 3/4 of an inch is really good. You could go as small as maybe 1/2 inch. Thinner than that isn't really recommended. As far as how many layers you need to do your floor, as many as it takes to get the surface that you want. So this floor is done in, if you just count the mud coats, it's done in 2 coats. 2 or 3 coats is very common. You could, in theory, do it in 1 coat if you had a really good mix and you wanted to just do it all at once. The main reason I didn't was because I only had straw to work with, and I didn't have a very good machine for chopping the straw. We had kind of a cheap leaf mulcher, which can work pretty well for chopping straw. You add fibers to an earth mix to add tensile strength. It also counts as a non-expansive additive to reduce the chance of shrinkage cracks in your earth. There are a lot of things you can use for fibers. You can use hair, you can use wool, you can use any strong, flexible, fibrous material. Mostly in construction, people use straw because it's a waste product. It's readily available and it works really well. We chop our straw because in a lot of applications that aren't just like a core wall or something, having the really long pieces of straw in your mix can be a little bit disruptive to trying to form whatever thing you're trying to form. In the case of a floor, having big long pieces of straw, because we're floating it out, we're using the trowels on it, we'd be catching these big strings of straw and ripping them around and pulling gouges in our floor and stuff like that. And so we chop it up so that the straw doesn't disrupt your ability to work the surface of the material. You can use full-size straw for something like a core wall, but when you start getting into thinner layers of material, or especially finishes, you want to chop your straw, and the finer the better. The manure of grass-fed animals is a great source for fibers for earth construction. The fibers are very finely chopped. All that's left in the manure is the strongest fibers that weren't able to be digested by the animal. All the sugars have been digested out of them, and you're just left with those strong, finely chewed up fibers, and they're fine enough that they work really well even in a finish. And not only that, manure also contains organic polymers, which are great once you get them wet and they activate. They can make an earth mix stickier, they can make it more water resistant, moisture resistant, and add all other good properties to the floor too. So the manure of grass-fed animals, especially horses and cows, because the package is big and light and fluffy and easy to break up. If you try to use manure from, say, a sheep or a goat or something, it comes in these little pellets that are a little bit harder to process and work out. But we just took Samantha's horse's manure, ran it through a 1/4 inch screen to get out any bits and larger pieces and stuff that we didn't want in it. I'm also sifting my material. For the 3/4 inch layer, I sifted the earth down to 1/2 inch to get rid of any rocks or clods or anything that might be in the dirt that would disrupt being able to lay the floor down as thick as we wanted it to. And then for the very top layer, which is 1/4 inch, I sifted the earth again down to 1/4 inch. I also did a less sandy mix for the very top coat. Another thing that encourages shrinkage cracks is when you have a lot of really thick material. Generally speaking, as your material becomes thinner as you get closer to the finish of whether it's plaster on a wall or layers of an earthen floor, as you get through those thinner layers, you can have more fines in the material, which helps make it more water resistant, make it stronger on the surface. Because it's thinner, not as much shrinkage is occurring, and so you can get away with having more clay in the top coats. And so I only added, whereas the layer underneath was a 50-50, I think I only added about 20% sand to the final 1/4 inch layer. I tried to do just the raw floor, just the raw earth from the lemon tree site. I thought maybe at 1/4 inch it wouldn't be thick enough to really crack, but I did still get some pretty decent cracks in the floor and some delamination that happened. When I was laying on the final coat, I didn't use any guides or any screed boards or anything like that. If we'd put enough effort into making the first coat flat enough, I knew that I could reliably eyeball the next coat that was going on without having to worry about it getting too far off. And I mixed in I don't know, maybe 20% horse manure in with the top layer to give it that extra non-expansive additive, and also just the tensile strength. And then on the third day, I went back and tested the floor. So after you've got your finished floor laid down, you want to make sure that everywhere is laminated really well. You want to check around, especially any cracks that are forming in the floor. Not necessarily a problem. You can repair most cracks especially if they're just superficial little hairline cracks. We had plenty of those on this floor. But you want to go around, especially the cracks, and push down around those cracks and see if there's any movement, right? If you push it and a little piece breaks off and compresses down, that's not laminated. And so I went through, and there were a lot of pretty bad cracks around the stuff that we had done the first day. So I went around, tested everything. I just kind of went around and pulled up the stuff that was very obviously delaminated. It was quite a bit. And so to repair those, if it's a crack that doesn't need to be pulled up, you just have to repair the crack itself. You can carve out the area and then wet it down really well. Wet it also in the area around the crack pretty well. Sprinkle some new material in, and then recompress that material into that crack area, float it in really well. The areas that were worse than that were delaminated, I ended up getting under and using my fingers to just pry up whole sections of floor where it was not connected to the floor underneath really well, and so it just pulled right up. I went through all those areas that were delaminated, I pulled them out, wetted the area really well, gouged it up just like I had done on the subsurface on the first layer before, made it nice and soft and mechanically tieable, and then put the fresh material in, wetted down around the edges really well, and then recompressed and refloated out all those areas. And at this point, you really can't tell where the repairs were done at all. When you're using a flat trowel like this, you can kind of rely on it to make sure that you have a flat surface, right? If you're working with this flat tool on a flat surface, it should glide around without any really resistance or bumping into anything or creating any lines. But if it is gouging in places, that shows you somewhere where the floor is uneven. You can use the tool to show you where those uneven places are. So this tool is called a Darby. This is a plastering tool, but it's a straight metal object. It's got a little bit of a taper to it and kind of a sharper end on this side. I can use this over the floor to take around and look and see where light is showing through and where it's not, and that helps me find the topography of the floor, those subtle changes in the height of the floor, and then I can take that sharper edge and I can even shave those down where there's high spots, and I can fill in low spots and make the floor even more flat. After all the repairs were made, on the very last day, the third day of doing that layer, I went over the entire surface with the wood float and a spritz bottle of water and just sprayed the area that I was working, kept it all wet, and just took the float over the entire surface of the whole floor and made it all nicer, took out lines and imperfections, filled in gaps, found any soft areas, resurfaced the whole thing, made it all look more consistent. So what happens when you spray the surface, when it's got the clay in it with the water, it gets wet, that clay expands and comes up to the surface, and then you can spread it out with your float. The wood float, of course, leaves a really rough surface where it keeps a lot of the sand exposed on the surface so it stays rougher. This is a metal float. This one is a magnesium float. This tool, if I were to resurface the floor with this, leave it with even like a polished surface. But if you're not relying on compression, you don't even necessarily have to have a rigid tool at this point. If you're just going to be going around doing the surface of the floor and not actually applying pressure down, you can use even a pool float like this, just a thin metal trowel, and just use that to work your surface and keep getting it wet, work the trowel over it, and it'll bring that clay up and spread it around and leave you with a nice smooth polished surface. So there was an area right here at the front where it meets the floor. I did just a little ridge here. All I did that was different right here was I added more fibers, because I wanted there to be more tensile strength, because this is actually a place where if someone's stepping right on that ledge, they're putting pressure that could cause it to break right there. To get this kind of like smooth corner on the front here, which we call bull nose, a lot of times in earthen construction, structural earth can be very strong material, but it's not that strong. It's still pretty vulnerable to damage from things bumping into it, chipping it, breaking it off. And so very often our corners in earthen construction, we round them off so that they're not sharp, because sharp earthen corners can wear down and be broken very easily. And so we do rounded off corners, and we call those bull nose corners. Before you've oiled it and sealed it up, the floor is infinitely repairable. And so I highly recommend spending time with the floor, walking on it, feeling it, making sure it's completely dried in, checking around the whole floor surface area, make sure that it's exactly how you want it before you seal it, because at this point you can repair it infinitely, and structural earth is the most repairable construction material. You could come back to this floor in 100 years and put the same earth into it and float it out just like it was today. But as soon as you put the oil on it, now you've added a chemical compound, a chemical reaction to the surface, polymerization, that is going to prevent that same level of repair. You can still repair it after it's oiled, but you'll probably have seams and lines that are still visible in the areas that you're repairing, whereas you can repair the raw earth floor to the point to where you can't tell that there's any seams in it at all. And so take your time, be patient, feel for not just cracks either. There are parts of the floor that could look perfectly fine, but you feel them, you press your finger down into them and they're soft. When I was going around this floor, I found several spots just feeling around with my fingers that were where it just didn't get good compression. And so the material there was soft. So I dug out where it was soft, which mostly were just really small spots that just didn't get hit with the trowel for whatever reason really well. And then I just filled in with new fresh material. And also I took all the material out, didn't just re-wet it and recompress it. Also because maybe it's not just the compression, maybe there was a bit of material that didn't get the right mix and it didn't get enough fines or something. And so I'd take that material out, put some fresh material in, recompress it and float it out and get rid of those soft areas. Once you're fully confident with the surface of your floor and it's how you want it, you can seal the floor. So we use oil to seal the floor. Most commonly people use linseed oil because it's the cheapest option, most available. You can go buy it at your hardware store. It's popular for sealing wood, so it's readily available everywhere. Keep in mind the linseed oil that you buy from the store probably has chemical drying agents in it, which will help it dry a lot faster. But if that's something that's important to you to have all natural products, you may want to order raw linseed oil online rather than just going and buying it at the store. Some other oils that will work, tung oil, which you can also buy at the store. And tung oil is great for doing countertops or things like that because you can oil it to the point where you even get almost like a lacquered finish. But any kind of hardening, polymerizing oil can work to seal a floor. Basically, if you leave it out in a saucer for a while and come back, there's a little plasticky film on top of the oil there. That's the kind of oil that you could use to seal a floor with. You want to also thin the oil out if it isn't already thinned. You can either heat the oil up or you can add a thinner like turpentine to the oil to thin it out, and that helps the oil penetrate deeper into the floor as well as dry out, how the coats will dry out faster. And yeah, you can heat the oil yourself just outside. Make sure you do it outside, make sure it's well ventilated, and obviously hot oil can be very dangerous, so be very careful if you're taking that route. Don't heat it up so much that it's going to melt your skin off if it gets on your skin. You want to make sure you apply the oil on in thin coats consecutively, letting it dry out completely between each coat. I recommend doing the first coat at least by hand with a rag. Dip your rag in the oil and then rub it on the floor until you cover the whole area. And I like to do at least the first coat by hand with a rag because it gives you one last chance to work the surface of the floor with that rag as you're going along, buffing out shrinkage cracks, little superficial little hairline cracks that aren't really a problem. They showed up, we were able to kind of buff those out a little bit as we were putting that first coat of oil on. But you can also apply the oil with a paint roller or applicator. They have applicators that you can put on the end of a broomstick, and they are for applying oil to wooden floors. You can use that on an earthen floor, and then you don't have to get down on your hands and knees. As far as how many coats it takes to seal your floor, again, as many coats as it takes to get the surface that you want. It depends heavily on how sealed do you want the floor, what kind of oil you're using, how are you thinning it, what is the atmosphere like? Is it very humid in the air? That'll make it take longer to dry? Do you have direct sun on the floor? Do you have plenty of airflow through the space? All things that kind of help contribute to how fast your oil is going to dry. We have kind of ideal conditions for drying here. The air is very dry. We have a lot of airflow. It's really warm right now in the middle of the summer. We were able to put several coats on immediately, one after the other, because it was just drying out instantly. Very often, 8 to 10 coats is pretty typical. If you're using just raw oil, it might be as little as 2 coats, or it could be as many as 20 coats. Maybe, you never know. It also depends how oiled do you want the floor. You can Oil it until you can scratch it with your fingernail and it's not dusty. That's kind of the minimum sealedness. You can keep oiling it though after that if you want, till you pour water on the surface and the water beads on the surface. Walking on a really well-made earthen floor, layered earthen floor, was one of the formative experiences that really made me fall in love with earth building and made earth building a lifelong passion of mine. And so I'm really glad to be able to give other people that experience, feel the coolness of the floor. Another thing, especially in the summertime, you can come here and lay down on this floor and it's going to be cooler than the air around it, probably because it's earth coupled. It's drawing the heat down into itself, and vice versa in the wintertime, especially if they decide to put a rocket heater in here. This floor will soak up that heat produced by the heater and then radiate that heat throughout the space and make it more efficient and make it more comfortable and make it so when you step onto the floor, it warms your feet up from the cold outside. There is a quality of softness to them that makes them really pleasant to walk on in a way that a concrete slab is not. Concrete is very brittle, and this material is plenty hard, but it has just a little bit of give to it that's almost like imperceptible. You almost feel like when you're walking on it, you might think that you're sinking into it a little bit, but then you move your foot and it's still just perfectly flat. It's almost a magical quality to a really well-made, well-layered earthen floor. Yeah, I'm really happy with how it turned out, and I hope that this video has been helpful and inspiring.